Bismillahirrahmanirrahim. Friends, I'm Mir Muhammad Wasik on your channel Mir's Electro World. Fellows, today we are going to make a blind stick for the blind persons so that they can easily walk without any injuries. For this purpose, what we need is we need a Arduino board, right? We need a ultrasonic sensor. We need a couple of jumper wires. We need a buzzer. We need an LED. We need a 220 ohm resistor. We need this data cable to connect our this Arduino board with the laptop to upload the code, right? So this is the interfacing for of the circuit, right? I'll explain it. This is our Arduino board, right? This is the board. Here we have the power ports. I'm connecting this. Have a look at the ultrasonic sensor. We have 4 pins here. This is the VCC. The second one is the trigger pin and the echo pin and the ground pin. So I'm connecting the ground and the VCC with 5 volts and the ground over here, right? On this power port, right? And the rest of the 2 pins will come. This is the echo and the trigger pin, and I'm connecting echo and the trigger pin at pin number 9 and 10, right? So echo will go to 10 and trigger will go to 9, and rest is we need to place our LED, and positive of the LED is connected with the pin number 6, and negative of the LED is connected with 220 ohm resistor, and the other side of the resistor is connected with the ground on this digital side, right? This is a ground over digital side. And in the same way, we are connecting the breadboard negative with this ground, right, and the positive with pin number 5. So that's all. This is the interfacing. Let's do the interfacing. For that purpose, I already placed these components right on this stick, right? This is the ultrasonic sensor. Better you place this ultrasonic sensor in a tilting position, like I already fixed it, right? And this is the Arduino board. This is the breadboard, and this is the battery to power the this Arduino after we code it. So let's start the interfacing, fellows. What we need is we need to connect the LED. So I'm connecting the LED now. Negative side over here and positive over here. LED is connected. Now I'm connecting the buzzer. This is the negative of the buzzer. This is the positive of the buzzer. Okay. Now I'm connecting negative side of the LED with this 220 ohm resistor, so it will not blow with 5 volts that is coming from the microcontroller, right? And now I'm connecting this with the ground on the digital side. This is the ground, right? Now I'm connecting the positive of the LED with the pin number 6, with pin number 6, right? And I'm connecting buzzer's positive with pin number 5, digital 5, right? It's up to you. You can use any other pins if you want, right? It's up to you. Now it's connected, and now the negative of the buzzer is connected with the negative side of the buzzer. I'm connecting it with this common ground, right? This is sorted. Now these are the 4 wires coming from the sensor. The red wire is positive, the black wire is negative for this sensor, and rest of the 2 wires, this green one is the trigger, and the yellow one is the echo pin. So I'm connecting it. Now I'm connecting it, the green with the pin number 10. It's up to you. You can use any other pins, right? And I'm connecting the echo here, pin number 9, and I'm connecting the positive of this sensor with 5 volts on the power port. This is 5 volts, and the negative to the ground over here. Well, it's all done. Yes, negative is here, negative is here. Right, now the interfacing is done, fellows. Now we need to write a code for this microcontroller, right? For that purpose, if you if you're using, then you need to install a software. We call it Arduino IDE from arduino.cc, right? I already make a video on introduction to the microcontrollers, in which I already explained. You can, if you want, you go and watch that. Go on to the files after installing it, right? This is our Arduino IDE. Select the new one and you get this thing. You have to place your code over here. So now I'm placing my code and I'm starting it. I need a constant integer, and this integer is basically I need two integers for trigger and echo pin. So this is the for trig pin, and I'm making it to 9. Now another constant we need, it's integer echo pin, and I'm making it to 10. You can use any pins, 6, 7, up to you. And now I need a long data type, because this ultrasonic sensor is basically sending these ultrasonic sound waves in the form of bursts. So we need a long to at least we have 32 bits of storage, right? Long duration, you can use anything, up to you. Duration, and another integer I need, this is the distance in centimeters, DISCM, up to you, you can use anyone, right? Distance in centimeters. Now I'm starting the void function, void setup. This is the setup function. I'm starting the setup function. Now starting the setup function, and I'm calling this serial begin, serial dot begin. Okay, and I'm placing the baud rate, that's 9600. We are using this because if you are using the these serial monitors and the plotters, then you can use this the baud rate for that. Now I'm calling the pin mode function, or if you're displaying on a screen, then you use the serial begin, right? Pin mode is an inbuilt Arduino IDE function, and this function is used to make any pin input or output. Now I'm making this trig pin as output. Trigger pin, so that because trigger pin is sending the burst of ultrasonic waves, and echo pin is receiving, right? So I'm making it output. Now I'm making the echo pin as input, again calling the pin mode function. And I'm making this echo pin as input. Now I need two pins to make as output for my LED and the buzzer. So I'm selecting 6 and 5, and up to you, you can use any other, right? I'm calling the pin mode function. I'm making 6 as output for LED, and I'm again calling the pin mode function, and I'm making 5 output for the buzzer. Now loop function will start from here, void loop, starting of the loop. Now I'm calling another function. We call it digital write, right? We use this function to make any selected pin as high or low. Means if it's high, it means we are passing the current, and if it's low, it means we're not passing the current, right? So I'm calling this digital write here. Digital write, and I'm making this trigger pin. This trigger pin low. Initially, I'm making it low. I'm making it low for 2 seconds, 2 microseconds. So I'm calling the delay function. This is also IDE function, delay in microseconds. Delay in microseconds, I'm placing 2 microseconds. It means initially this trigger pin will stay at low for 2 seconds, and now it gets high. So again, I'm calling the digital write, and I'm making this trigger pin high. So we need to make it high. Let's see. I'm making it high for 10 microseconds. So I'm calling the delay function again, so that we can receive the burst, right? These burst of these ultrasonic sound waves. Now I'm placing the delay microseconds for 10 microseconds. It will stay on to throw the burst of these sound waves. Now I'm again calling the digital write function, and what I'm doing is now I'm making this trigger pin low, because in these 10 microseconds we already got the burst, right? I'm making it roll low, so trigger pin to low, trigger pin low. Okay, now I already use this duration. This is a long type of a duration. Duration is equals to, again I'm calling pulse in function, pulse in. It's inbuilt function, Arduino's inbuilt function, right? And this function will send the pulse, stay for some time, so we call it pulse in function, right? And I'm passing now that pin that on which I'm receiving these sound waves, ultrasonic sound waves. So I'm passing the echo pin here, echo pin to this pulse in function, and I'm making it high. Now I already declared this integer distance in centimeters. Now I'm using it. Distance in centimeters is equal to, we are using the famous formula S distance, S is equals to V into T, velocity into time. Now this is distance is equal to velocity into time. The time is the duration, right? I'm calling the duration here. Duration will multiply with the speed. S is equal to V into T. T is this, we are multiplying with the V. And now the velocity of sound is 340 meter per second, but we are manipulating in centimeters, not in meters, and it's two-sided. So I'm dividing 340 with 10 raised to the power 4, and what I get is 0.034. Okay, and I'm dividing it with 2 because I need one side, of the wave that is coming when it is striking with the obstacle. When it comes back, I need that one side, so that's why I'm dividing it with 2, so I can get the distance of one side, right? So this distance will come in distance in centimeters. Now if you are using these tools in the like serial or the serial monitor or the plotter, you can place any delay here up to you, like a delay of like 100, right? Now comes the condition on which we are on which we are making decision, right? Now I'm bringing this if condition. If this centimeter, what I get in this centimeter, if this distance in centimeter is less than, let's suppose if I'm making it for more than 1 feet, so that mm, this blind person can get attention on 1 feet or more than that. So I'm placing 45, less than 45 means till 45 44 seconds. If some obstacle will come in this range from that person, it will work, right? Condition will get true. Now this is the if condition. If distance in centimeters is less than 45, it means obstacle is in front of the this blind person. So I need to make these the buzzer and the LED high. So I'm calling the digital write function, and I'm making this pin number 5, that is for buzzer write to high, and I'm making the LED on 6 high as well. So I'm calling the digital write again, and I'm making this pin number 6 as high. They both get high. It means obstacle is in front of us. Okay, now we need to check the other condition. If there is no obstacle, then else condition will come here and it will run. If there is no obstacle, right, else this I'm calling the digital write, this digital write, and now I'm making both of the buzzer and the LED low. It means there is no obstacle in the range of 44 centimeters. And again I'm calling the digital write, and I'm making pin number 6 low as well. It means there is no obstacle. That's all else, and I'm closing the loop functions bracket. So here we are. Let's have a look. Hope so the code is fine. I'm make a double check here, right? It's send high lows. It's done, fellows. Now what we need to do is we need to upload this code into this microcontroller. For that purpose I'm connecting the microcontroller with this data cable with my laptop, right? Here it is. Now I'm compiling it. Use this button for the compilation. I'm saving it with my name, Mir Vasik. Saved. Now compilation is going on. Compilation is done, fellows. Now I'm uploading the code. Uploading is done. If you're first time using it, make sure go into the tools and select the board. I already selected Arduino UNO and the communication port. I'm on communication port 4, right? Select both of them, otherwise it will not work. Now the code is uploaded. Now we'll see it's working, fellows. Now I'm just you see, when I'm bringing the obstacle, it's up to 44 centimeters, right? Let's have a look. Now the buzzer and the LED is glowing. You see, buzzer and the LED is glowing. When this obstacle will come, this buzzer and the LED is glowing, right? So it's uploaded. Now I'm connecting it with this battery, right? It's a 3.7 volts. I'm using two 3.7 volts cells, right? So that I need more than 6 volts. Now I'm connecting it. Already code is there. I'm connecting the microcontroller with this thing, and what is the problem? We'll see it. It looks like this battery is battery is not working anyway. Look like battery is dried. We need to recharge the cells, right? Anyway, now have a look. If this is the stick, right, and if the obstacle will come, like this is the obstacle, right? Let's see. If the obstacle is here, okay, it is indicating. You see? Well, I'll see what is the problem with this battery. I'll have a look. Actually, it's not 6 volts, that's why. We need to charge this battery anyway. Again, I'm trying if it will work. No, it's not working anyway. We need to charge the batteries. Better you put new batteries, right? Now, have a look. When obstacle come in front of this blind person, let's suppose there is no obstacle. Now the obstacle comes. Okay? You see? On 44 seconds, make a full image of it, right? Full image of the stick. You see? There is no obstacle. It's fine. Now the obstacle comes and the buzzer and the LED will, you see, they both are now glowing. So that's all, fellows. Hope so you like this project. And gentlemen, if you like this video, fellows, click on the thumbs up button, share my videos with your friends, and subscribe my channel. And thanks for watching.